Okay, so hi everybody. I have been asked by several students to provide an alternative gas law baggie project. And so that's what this is right here. This is for anybody who feels like they either can't collect the data or maybe don't know how to do the math. That's what this is all about. So let's go ahead and take a look at what we're looking at. So we're changing the problem statement to what is the amount of baking soda and vinegar that can be mixed to fill a zipper style baggie with a gas to a pressure of 1.25 atmospheres. So for this activity, you're going to practice problem solving, reflection, and gas laws calculations. You are probably still going to want to watch my video so you can see what the materials would have been. So there's that video right there. You are going to be doing some different kind of reflection in this. For this one, you're going to reflect if you had the ingredients and supplies needed to do this experiment. Then you're going to say, well, how would I have set this up, and how would I have done the data collection? So you're going to write about the process you would have done if you could have. Then you are going to complete all the calculations written out showing your work, even if you had to ask Google how to do the work, so that you can be understood. Make sure that you label them and you give headings and unit labels so that I know what you're talking about in your calculations. And you can use the calculations as a handwritten or typed information. Either up to you is fine. You can type it into your Google paper, or you can take a picture of it and post it inside there. All right, next we get to your data table. And in the data table, we are going to um, need to look up what is the balanced chemical reaction for our two reactants. And our two reactants are baking soda and vinegar. And you will want to reference Google here so that you can figure out what is the balanced equation for this reaction. And then you'll notice that the data table has changed a little bit. And so you'll notice that the room temperature is given to you as 22 degrees Celsius. And that's going to stay the same for all 5 trials. And you're going to notice that there is a space for you to record what that would be in Kelvin. So that's your first calculation that you're going to show work for. Then you are given information about how much baking soda to use. And so I have given you a range of 1 tablespoon, a quarter tablespoon, and as you're going to see, other values of tablespoons. And that's going to change. And you'll notice that the baking soda has to be converted to grams. And so when you get to the calculations, you're going to notice that I am asking you to refer to Google and ask Google that question. And so we'll talk about that question and what that means for you when we get to the calculations. Then you're going to notice that I have placed in here that vinegar is a 5% solution, and the amount of vinegar is approximately 59 milliliters. So you're going to notice that that amount stays the same throughout the whole thing. Now, if you're wondering what that is in cups, I believe that equates to approximately a quarter cup of the vinegar, a quarter cup of the vinegar if you were measuring it. So this is 59 milliliters. And we are going to use the density equation to convert vinegar in milliliters to vinegar in grams. So you're going to need to do that using the density equation. Be sure you include the fact that it is only a 5% solution. So you're going to want to take 5% of whatever your grams are. That's going to be 5%, and that's what you're going to use for your grams. Your baggie volume is given to you in milliliters, so there you go. That is another value that remains the same. So far we have 3 constant variables: room temperature in Celsius, vinegar in milliliters, and baggie volume also in milliliters. Okay, so you are still going to have to do the calculations that go along with this. So we'll notice, please, that we have the rest of your trials here. Under the procedure, here's where you're going to write in your reflection that explains the process you would have completed to do the data collection. Anything that you felt like you should have done, even though you're not doing it, anything you feel like you should have done whenever possible. Explain any problems you envision that might have been an issue. I know that there are already problems with not having enough supplies or not having the ability to do it. I understand that. I want you to envision what problems, if I could have done it, what problems would I have had, and then make sure you talk about how would you have solved these problems. So you're going to think in terms of what ifs, all what ifs. And then we get down to our calculations. And I have tried to provide a roadmap for you for how to do the calculations and some simple pointers to follow. So you're going to show your work for one of each of these types of calculations. Please include your unit labels and significant figures. You don't have to do it for every single trial, but you do have to do it for at least one trial. Okay? So the temperature changing from Celsius to Kelvin, the volume of the baggie changing from milliliters to liters, and I think I wrote volume of the baggie twice, so let me erase this here because that was a repetition there. Okay, so the mass of the baking soda from tablespoons to gram. It is okay to use a Google search for this. Please record what site you use, so there should be a URL address copied and pasted right here to say what site you use to determine the mass of your baking soda in grams. And so please use a Google search for that. Then you're going to do the mass of your vinegar from milliliters to grams using the density equation. And then you're going to use, and I've provided you a skeleton here of a mass to moles problem. So you're going to convert mass of your baking soda and mass of your vinegar to moles. Now, let's be clear here. You have amounts of two reactants, the baking soda and the 5% vinegar solution. So that means you have to do two of these mass to moles calculation. And giant hint, everybody, please make sure you remember that when we have two reactants, we have to figure out which one is the limiting reactant. If you have to go look up what is a limiting reactant again, please use Google to do that. If you end up with questions after you have looked it up, please then send me a message, either email or as a note on this post for how do I find which one is the limiting reactant and therefore which one is the correct moles of the CO2. Finally, the last thing you have to do is use the ideal gas law to calculate what is the pressure of the gas in the baggie. I have told you that I want you to have 1.25 atmospheres, but you actually are going to have to measure the pressure of the gas, calculate the pressure of the gas in the baggie to figure out which trial is actually the trial that will work the best. I will tell you, none of the trials will come out exactly as 1.25 atmospheres. So you're going to have to use your best judgment of which one do you think will do the best to fill the baggie to that pressure. Okay, so if there are any questions, I will be having another Zoom meeting tomorrow in Classroom so that you can, so you're going to go to Classroom tomorrow and you're going to find the Zoom meeting. It will be posted tomorrow and you will have the ability to ask questions in person at that time. I hope this helps everybody. If you still have personal questions that you'd like to ask, please send me either an email or post a question at the bottom of this posting in Classroom. In all cases, please stay safe, stay healthy, and I am willing to extend this deadline to Monday, and so that would be Monday, April the 6th. So I would be glad to extend this deadline to Monday, April the 6th. All right, thank you everybody, and stay safe. Bye-bye.